Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, today we'll discuss about another physics paper, JEE Mains Physics 2014. So let us discuss all these questions one by one. Assume that an electric field E of 30x square I cap exists in space. I cap means that it is in x direction. This is our coordinate system x, y and z. I cap is always in this direction. This is I cap, unit vector in x direction. And the electric field is given as, this is a electric field is given as 30x square I cap. Okay. So this gives you the magnitude part of the electric field, and this I cap gives you the direction. The electric field always pointed in one direction, that is along the positive x direction. So now and obviously this is not a constant electric field, this is a non-uniform electric field. You can see that as you change the value of x, this E will change, because if put x equals 0, this electric field will be 0. Put x is 1, this is 30. Put x is 2, this is 120. So therefore, as you move along away from the source, suppose here, then the electric field is increasing. Okay, then the potential difference between A and VA and VO, the potential difference between VA and VO, that is VA minus VO, where VO is the potential at the origin. This is the, suppose that is the origin, this is the origin 0 0 0, but this point and any point somewhere, suppose here A, then here the potential is I'll use another pen. Suppose the potential is VA and the potential of the origin is VO. So what it says, the potential difference VA minus VO you have to find at x is 2 meter. So x is 2 meter means I will consider a distance which is 2. I will consider a distance which is 2 meter. So at x equals 2. So then you have to use, you know, that the potential difference in terms of electric field. Then we all know that there is the concept to this is that if we have any 2 point in the electric field, suppose this is the electric field, we have any 2 points, say A and B, then we know that the potential difference between those 2 points, that is B minus VA, the potential difference, that is the final potential minus the initial potential, BV minus BA. Here it is, the final potential is this and the initial potential is this, so BA minus VO, that equals to minus the E electric field dot dx. This is the, and integrate it from the initial value to the final value, say A to B. This is the formula, because electric field is a negative potential gradient. So basically electric field also, you know that this is negative potential gradient. Okay, this way we write negative potential gradient. So if I take this to this side, and the dot product of this E dot dx will give you the potential difference. This is just the derivative form and this is just the integration form. So we'll use this concept to solve this question. Now if I use that, I have this is the origin and this is the point A, which I have to move from x is equal to 0 to x is equal to 2, because at 2 you have to find the potential difference. So this point the potential I will at VO, this point potential at VA. I know that VA minus VO, potential difference between the 2 points is minus E dot dx. I have to take the integration varying from 0 to 2. This is the lower limit, x is 0, x is 2. Now VA minus V naught can be written as minus of E dot dx. The electric field value I have to put here in terms of dx, in terms of x, so that I can solve the integration. In the question it is given 30x square. This is given 30x square. I will substitute that, and this dx is also in this direction. The dx vector is in this direction I cap, and the electric field vector also is in this direction. So this cos 0 is 1, because A dot B, we know that A dot B is AB cos theta. A dot B is AB cos of theta. So if theta is the angle between the two vectors, this electric field vector and dx vector are all pointing in the x direction, so the angle between them is 0. So I'll put cos theta equals to 0. So cos 0 is 1. Finally this will give you 1. So this means this is only E dx. So I'll write magnitude of the E vector, magnitude of this vector, and magnitude of this vector, and cos of 0, and integration x is 0 to x is 2. Now I have to write this VA minus V naught equals to magnitude of this is 30x square, that already we know that is 30x square, and dx magnitude will be dx only, and that we have to integrate, minus is there, and it varies from 0 to 2. X is 0 to 2, x is 0 to x is 2. Then we can solve this, and we have VA minus V0 and minus integration of 30x square. 30 comes out, x square integration is x cube by 3. X square integration is x cube by 3. This all goes from 0 to 2. This is the integration of the last equation that I got. Now this is minus 30. This is 3 square. Sorry, x cube by 3. 3 is there, 3 comes out, and only x cube part you have to put the upper limit here, lower limit here, and this is 2 raised to 3 minus 0 raised to 3. This comes out to be minus 10, and this is 8, and this is 0, so it's 8, so it's minus 8 into 0, that is 80. So this potential difference between the 2 points starting from origin to the point A, here at a distance x is equal to 2 meters from origin, here it comes out to be minus 80, and here the difference is minus 80. Obviously here if I consider this to be 0, then the potential difference, this minus this, is minus. So the difference is negative, means this is at lower potential and this is at higher potential. Okay, because minus 80 minus 0, if I consider this as 0, then minus 80 minus 0 is minus 80. So this is at the lower potential. Anyway, this is the potential difference, is minus 80, and according to the question, the potential at x2 is minus 80. That is the answer to this question. So minus 80, this is the answer to this question. Okay, then the potential, and one mistake is there, that is should not be in joule, it should be in volt. Potential difference is in volt, not in joule. Okay, thank you.